So, welcome to Rappin with Reverend Laura. We have previously used this as an opportunity for people to submit questions, and I would answer them, but we ran out of questions. Apparently, my answers were not that great. So, I decided that I would turn this into an opportunity for me to interview people because after my dialogue sermon with Reverend Max Ramsey, we had a ton of people express appreciation for that opportunity. So when you're asking people to come on and be interviewed, you start with the people closest to you. So our guest today is my daughter Ruth, and I will have her introduce herself and tell us a little bit about what she's doing. And I invited her not just because she's my daughter and she's awesome, but also because she um, I asked her to speak specifically about science literacy. And so, because that's an area of interest and expertise for her. And with the whole COVID thing, we've learned a lot about science literacy in the midst of this. So, Ruth, tell everybody who you are and what you're doing and what your credentials are.
Hi, I'm Ruth McLeod. I am currently a fourth year in a PhD program at the University of Connecticut, where I'm in the psychology division. My specific branch within psychology is behavioral neuroscience. So I look at how things that happen in our brain, both chemically and injury wise and genetic wise, affect our behavior. So that's what I'm getting my PhD in. I specifically look at injuries that happen to premature infants, so infants that are born too early, and how we can potentially treat those injuries to help have better outcomes as those children grow up. Um, so that's kind of what I do in my day to day. I'm also a member of a program at UConn called the Science of Learning and Art of Communication, which is focused on teaching graduate students how to communicate their research and how to kind of bridge the gap between public understanding and scientific academic understanding, because that's a huge issue in science, and we can see that very clearly with a lot of the misinformation that goes around about COVID and other scientific issues. So that's kind of where my focus is.
Awesome. She's smart. Uh, she obviously got all her brains from her mom. Um, so I know that, tell them a little bit about what your goal is, like what you hope to do with this.
Yeah, so hopefully within the next couple of years, I will have finished my PhD program. I'll have defended my dissertation and I'll be a doctor of philosophy. Um, but I hope to either go into a teaching focused institution. So do a lot of education of college students with a little bit of research on the side, or go into a science communication or outreach program. So, like working for a museum and being their science outreach person. So, the person who brings scientists in to talk about their work with the public, and the person who runs those kind of education campaigns. Um, Teaching is something I really love and I think is really important. And I can get a little bit on my like science literacy soapbox about why we all should understand scientists and scientific writing. Um, but I don't know how much detail you want me to go into there. So,
Well, we'll keep it basic for people like me, but
Mhm.
tell first of all, I know that that's your one of your favorite things to talk about and teach. So explain what is scientific literacy.
Yeah. So scientific literacy, just like, reading literacy, right? So that's the ability to see something that's written and understand what it's communicating to you, right? So scientific literacy is the ability to take in scientific information and understand what it's trying to communicate to you. Um, so it's not people kind of get scared when you talk science literacy. They think I'm going to hand someone a 20-page article with a bunch of graphs and figures and statistics and ask them to understand it all. That's not what science literacy is. Science literacy often focuses on the ability to filter through all of the information that we're taking in because we live in an internet age. There's a ton of stuff getting thrown at us every day. So, scientific literacy is the ability to check your sources. It's to find out where the information that you're intaking is coming from, be able to judge if that information is trustworthy. And then also, if you really want to get into it, to go to that original source of that information and see if you actually agree with how that study was run.
Mm.
If you can understand, kind of the ethics around science, um, understand the system that puts science information out there and why some information is more trustworthy than others.
Cool. So, like in the my racial justice work, one of the things that we have to do is vet our sources. So
Hmm.
we have to do like a deep dive in understanding like what is the point of view of this person, where what is their background, where were they educated, what does that system believe, so that we understand their point of view. Is it similar to that, except you're doing it in terms of like the data?
Yeah, absolutely. Data and methods, right? So,
Okay.
um, science has a weird publishing system.
Mhm,
So the science that you often consume, you read it in an article from CNN. That's called a non-peer-reviewed source. So that means that it's meant for the public, which is why you read it.
mhm,
But it's often meant to have a purpose to either entertain or convince you of something. Right? That's kind of what those
mhm,
articles are for. Um, on the more academic side, we tend to use what are called peer reviewed sources. So these are sources that go through a really, really rigorous process before they're published, where the researcher has not only done all of the work of the research, but then they have to send that research and that writing to several other experts in that field. And those experts basically get a chance to critique the work. So
mhm,
they can say, hey, I think the amount of people that you used in your study was too small. I don't think this is valid. We're not going to publish it.
mhm,
Um, so the information that actually gets published from the scientific community is really rigorously reviewed.
mhm,
And again, that's not always a perfect process. Some
mhm,
things get through that shouldn't. Not all journals are created equal.
mhm,
Um, but it's kind of the best system we have to ensure that the best information is getting out there. And often, the CNN article, the, article posted by BuzzFeed, right?
mhm.
Those often are sourced from a peer reviewed resource.
Okay.
Um, and that's not to say that you have to read the peer reviewed resource, because often those resources are super technical, really, really hard to understand. Um, but that doesn't mean that they're impossible to understand. It's just important that you understand that process,
Mhm,
that, the article that your friend shared on Facebook, chances are hasn't gone through that rigorous review process that we require scientific work to go through.
oh, okay. Yeah. So when you teach this, what, um, okay, so for somebody like me who is not science minded, and
Mhm.
and who the idea of digging deep into like a scientific, paper would be like mind numbing. What's the most important part that the average consumer of that kind of information would need to know?
I think it's like you said when you have to do your source vetting,
Yeah.
it's really important to know the perspective of who's writing the article,
Mhm.
right? So I don't want to ask, obviously, we all have limited time, right? It's my job to go through resources and vet them, right?
Right.
That's part of what I get paid to do. Um, but you have a life, you have kids, you have work obligations, you have to feed yourself. You don't have time in the day to vet every piece of information that comes to
Mhm.
you, and go back to that original article and try and struggle through. If people have questions about reading original work, I can help. It's often a lot simpler than people think, but Um, um, but it takes a lot of time and a lot of practice. Um, what I would recommend is same with your vetting process. When you're reading an article that you saw on Facebook or that came up in the news, try and put yourself in the mindset of where are they getting their information
Hmm.
and what are they trying to convince me of.
That's, yeah.
um and then from there, again, sometimes convincing people of something is good, right? Like
Hmm.
if people are sharing vaccine information about the COVID vaccine because they want you to take it, I support that position. Right?
Hmm.
So I think you should get your COVID vaccine. All of the research says it's safe. I've read that actual research, right? It's safe to use. But right, so like a lot of articles about the COVID vaccine are going to be trying to convince you of that position.
Hmm.
Um, but also there might be some articles that are trying to convince you not to do that, right? So you just need to keep in mind, where is that information coming from? What is it trying to convince you of? And that doesn't necessarily mean that you need to listen to it or not. It's just something to keep yourself aware of.
Hmm. Cool. You had some slides you wanted to share with us.
Well, the slides I have are mainly focused on my work
So
as like
tell
a
us about that.
researcher. Okay,
Yeah.
great.
Tell us about
um,
your work, because
so
I'm fascinated by it, but
yeah, so I can talk about it. So my work, again, I study premature infants, and the brain injuries that they tend to get. But I'm specifically focused on one particular injury called hypoxia ischemia.
mhm,
So hypoxia means lack of oxygen, and ischemia means lack of blood. And so it's an injury that happens when the brain is cut off from blood and oxygen,
like a stroke.
like a stroke. Yep, it's like a baby stroke.
Okay. Baby stroke.
That's pretty much what it is.
Yeah.
There are lots of different ways you can get this injury. Sometimes it's actually caused by a bleed in the brain, which means the blood isn't going to the right spots. So
Mhm,
those places that it's not going to get injured. It can be caused by trauma at birth. So, this can happen more often with term infants, but if there's some birth trauma or like the cord is wrapped around their neck, or they don't breathe right away, that can lead to kind of these hypoxic ischemic injuries. Um, but yeah, so I'm interested in those injuries and their potential treatments. I model this both in humans and, well, I don't model it in humans. Oh God, that would be
it happens.
it happens. It happens in humans, and I study it.
Right.
I model this in rats.
Hmm.
So I work both with people and rodents. And I can kind of show you a little bit of what we do. So I'm
Hmm.
going to share my screen and then share my slides.
Hmm.
Give me one sec. Get to peek behind the curtain.
Nice screensaver
Thank you.
or background.
There we go. Okay.
Oh,
So
it's
this is
easier to
just from
draw.
a presentation I've given before.
Uh-huh.
But basically, you have your preemies and your little baby rats.
Hmm. And
Very
why
exciting.
rats?
So rats are actually born neurologically premature compared to humans. So their brains aren't quite ready to go
Uh-huh.
when they're born. So we tend to operate on rodents that are about 5 days old.
Hmm.
And that is equivalent to about a 28 to 30 week premature infant. So
Wow.
an infant that's born like 10 weeks early.
Okay.
Um, and you get some interesting results. So you can kind of see here, we have the in humans, the incidence of hypoxia ischemia. So as you can see, 40 weeks, it's pretty low instance, but as you get earlier and earlier um, in prematurity, you have a higher instance of these types of injuries. These injuries can range in severity. Not all of them are super detrimental. Actually, the earlier you get them, the more likely you are to recover from them.
Hmm.
So these injuries, even though they happen less frequently, are more likely to lead to detrimental development.
Okay. And GA is gestational age?
GA is gestational age. Yep.
Okay.
So just the total, this would be a term infant. So an infant that's born on its due date is 40
Okay.
weeks old.
Okay.
Um, but yeah. So again, the instance of term infants that experience HI is pretty low, but as we get earlier in prematurity, we see more of it, which is why I study it there.
Right.
When you have a premature infant that gets injuries, you can have different things that happen. Basically, all this image is saying is that basically, when you have a preemie baby that gets a hypoxic ischemic injury, they're more likely to see that injury in the white matter of their brain.
Okay.
So in your brain, you have white matter and gray matter. Your gray matter is all of the cell parts that are doing the thinking, right? And the white matter is all of the connections between those different gray regions.
Okay.
Mhm. So in premature infants, we see that injury in those connective areas, whereas in term infants, we see that injury in the gray areas, which are those like where we actually do the thinking part.
Okay.
And you can see that there are some IQ effects when you have infants that are born too early and experience HI. Current treatments for term infants are actually hypothermia, which is really fascinating. So you actually lower the baby's core temperature, which actually protects the brain. It prevents cells from dying because of these injuries, and it's really, really beneficial. But we can't do it in preterm infants because it doesn't work. So what I'm studying at least is the use of caffeine in preterm infants as a way to prevent these injuries.
So how does the caffeine work?
I'll get there. Just
Okay.
you wait.
Because I'm participating in it right now by
Hey, it's a
Mhm.
little different. We're injecting them with
Great.
caffeine. But first, to kind of show you the benefits that we see. So in animals, what I do is I do a little tiny surgery on these 5-day-old rat pups, and I cauterize their carotid artery.
Mhm.
It's little tiny microsurgery. I do it under a microscope. Then the little rat pups recover. We return them back to their mom or dam, where they get to be fed and comforted. And then we grab the pups again and we place them in a low oxygen environment. So that's going to be that hypoxia
Okay.
for 90 minutes. And then the combination of the surgery and the low oxygen is going to lead to an injury on the side of the brain that we cut that artery. And what you can see is, so a sham animal is an animal that hasn't had any manipulation done to it. So this is an animal that went through the process. So they had their carotid artery cauterized. So they lost their blood supply to that side of the brain, and then they had low oxygen.
Okay.
And you can see that's a pretty big injury.
Yeah. Is that like cell death? Is that what that is?
Yeah, so this is all cell death. So basically, this part of their brain in their skull was just kind of full of fluid
Okay.
when it was done. You can actually, in the animals that have a really successful HI operation, one eye actually gets smaller because there's less pressure on that side of the skull pushing it forward.
Oh.
Um, so that's the HI animal, but then the HI caffeine animal, we can see, they've got some differences in size, right? This side is a little smaller.
But that's an
But
amazing recovery.
it's pretty impressive, right?
Mhm.
So they recover pretty quickly.
So the brain is really resilient.
Mm-hmm. It is, especially at this age.
Yeah.
Which makes it really cool to study these injuries, but also a little challenging because oftentimes by the time these preemie infants reach the age of 3, it's like, oh, there's no more difference.
Right.
Where'd my injury go?
Right. Which is good. That's what you
Which
want.
is good. We want that. But there are also sometimes lasting effects that we can't detect right away.
Mhm.
And that's another thing that I'm studying is what are the long-term effects of this injury.
Mhm.
So caffeine is used as a respiratory stimulant in preterm infants. So for infants that are struggling to breathe or coming off of being intubated, will be given caffeine to help them breathe on their own. But why might it protect the brain, right?
Mhm.
So there are a couple of theories. The first, yeah, it gets big. Don't worry, I'm going to walk you through it.
Okay.
So
My brain's shut off right
adenosine,
now.
So adenosine is a neurotransmitter, right?
Okay.
And adenosine makes you sleepy.
I'm loaded
That's
with it.
why caffeine makes you awake,
All right.
right? So adenosine, when we're talking about what helps and doesn't help a cell, is we have all these different adenosine receptors, and some of them excite this process, which eventually leads to an influx of calcium in the cell. Now, calcium, if you have too much calcium inside of a cell, the cell actually dies.
Okay.
So, when you have a hypoxic injury, so when the brain is cut off from oxygen, all of the cells release a ton of adenosine.
Okay.
And so that adenosine is going to activate all of these receptors. You can see there's more excitation
Mhm.
of this process, which is going to lead to this influx of calcium. And that calcium is going to kill the cell.
Okay.
So, what caffeine does is it comes in and it's going to block all of those receptors.
Oh.
And it's going to slow down this calcium influx.
Okay.
And so it helps protect the cell. So that's on the neurons themselves. But
Okay.
our brain has more cells than just neurons. We also have support cells called glial cells. And there's a particular glial cell called a microglia. So a microglia is sometimes called like the immune system of the brain. It's what helps clean up the sick neurons or sick cells and get rid of them.
Okay.
So this is just showing that it stops that process, which is going to stop the calcium that comes in.
Okay.
So you have these inactive microglia, and these microglia have little adenosine receptors on them. But when there's too much adenosine, it's going to lead to this microglia becoming active. Now, an active microglia isn't a bad thing, right? Again, it's cleaning up our brain. That's what we want it to do. It's acting like our brain's immune system. But active microglia release a lot of inflammation, and that inflammation can actually increase cell death. So,
Okay.
what happens when you have this overflow of adenosine in the brain is you actually get microglial overactivation,
Okay.
right? So they get too excited. And then that's going to lead to this increased inflammation and cell death.
Okay.
But when you add caffeine, right, it's going to block that receptor and it's going to stop the microglia from becoming active, which is going to stop that increased inflammation and stop the cell death.
Oh. So caffeine is as a is like is stopping the death process.
Yes, that's what we think is happening.
Okay.
Here's the tricky part. We don't actually know for sure.
Okay. Hence research.
Hence what I'm trying to do. So I do some staining studies, which is where we color the cells of the brain to try and see what's happening. And I also do these behavioral studies where we look at how different levels of caffeine, different timings of caffeine affect the behavior, which can tell us a lot about how much damage there was.
Cool.
Yeah.
Is it time for follow-up questions?
Yes, please go ahead.
Are you done
I
with your
can,
slides?
yeah, let me stop
Okay.
sharing. My
So
info dump is over.
okay. Why is that this area of study under psychology?
It involves the brain.
Okay.
So that's the tricky thing, right? So I am in a very particular area of psychology
Uh-huh.
that kind of straddles the line between neurology and psychology.
Okay.
So psychology often considers itself the study of behavior,
Uh-huh.
and neurology is the study of the brain.
Mhm.
And I study behavioral psychology, neuroscience, neurology.
Okay.
So I study both that behavioral aspect, which involves different disorders like autism spectrum disorder, um, attention deficit hyperactive disorder, ADHD, dyslexia, and different types of language and reading impairments.
Okay.
Um, that's all kind of behaviorally measured in psychology. You get those diagnosed by a psychologist.
Mhm.
But I also study those really fine-tuned, like cellular mechanism stuff, which falls more into the neuroscience category.
Mhm.
So behavioral neuroscience, sometimes it's called neuropsychology, kind of straddles those two
Mhm.
realms. Because the thing is, it's really hard to separate our brain from how we behave, right?
Exactly.
Things just don't happen in the brain independently.
No.
Um, it's we are embodied minds, right? So our brains don't just exist somewhere out in space and they do stuff and it's fine. The stuff they do affects how we live and think and act. And so that's kind of why neuropsychology and behavioral neuroscience is where my work sits. I also, in my undergraduate education, really, really liked the idea of neuropsychology. And that's why I particularly was looking for a program that had that,
Cool. I have one more question for you.
please.
Um, as a preacher's kid,
Hmm.
where do you see, how do you see the intersection of faith and or spirituality, whatever you want to call it, and science? Because so many people think of those things as incompatible.
Yeah.
There's science and there's religion.
Oh,
Yeah.
I know. And psychology is actually one of the worst
Are
at
they?
that. Yeah, because psychology apparently they can see why people would need religion and faith,
Yeah.
and so they then don't believe in it, which I think is psh. Um,
But
for me,
there are famous psychologists or psychiatrists who kind of bridge that a little bit, like Carl Jung and people like
mhm,
that, who um, could see the benefit of those, or the relationship of those things, not the benefit.
yeah.
Yeah.
Well, and for me, the deeper I get into science, the
Mhm.
more it kind of affirms my faith that hey, there's got to be something out there
Yeah.
because things be crazy.
Yeah. Yeah.
um, for me, I remember in high school, I think I told you about this. I came home from a chemistry lesson being like, I think I believe in Jesus now.
Really, I don't
um,
remember that. Refresh my
it was because of hydrogen bonds. So hydrogen bonds are what happens in water. Um, Basically, the hydrogen pulls some more electrons near it, which makes it negative, and then the oxygen on the water becomes positive, and then it forms these kind of weak bonds with each other.
okay.
And if it wasn't for that thing, no life would exist.
Wow.
um, and the fact that it just happens to work out that way,
Right.
or that water is the most prevalent thing on this planet, and that's what allows us to live the life we live, um, is incredible to me and a very spiritual experience.
Yeah.
I kind of think, obviously, I'm a scientist. I believe in evolution. We are members of a church that believes in evolution and
Uh-huh.
believes in science. Um, and I think that the more I dig into the hard science of how the world works, the more I think that there's no way that all these things could just be a coincidence, right?
Right.
Um,
Yeah.
because everything's so complicated and so many things could have gone wrong
Yeah.
that didn't and were here. And I also look at the resilience of the brain. So these premature infants that have these terrible injuries, they're struggling to breathe on their own, they're not doing well, that then come back. The doctor I work with had a patient who turned 18 for her 18th birthday. She wanted to come meet the team that cared for her while she was a premature infant.
Uh,
She's doing amazing. She's going to
right.
go to college. She's like
Right.
doing all this cool stuff.
Yeah.
Um, and she was so sick. And the resilience of that, I
Mhm.
think like it's incredible. How could you look at that kind of experience and not believe that
Mhm.
something is out there?
Yeah.
Um,
That's kind of the way I feel. I mean, science to me is so out of my realm of uh, capacity to understand that it's like almost mystical. It's like looking at the stars, like, oh, I don't even get how that works.
mhm.
The same I feel looking at your diagrams of how things work. I'm like, oh, wow, that's pretty deep. So
Yeah. Well, and
but
I
the fact
think
that it all comes together to create like us, and that most of the time it works.
I
That's like
think
shocking to me.
I know. It's impressive. And I think there is a stronger relationship between our particular brand of congregational Christian religion and
Yes.
science. Right? Science is all about asking questions,
Yeah.
right? It's about asking why and how. And I think a lot of what the UCC does is it asks why and it asks how and it asks where and when and who. And I think that questioning, that I was able to grow up in that environment that allowed me to ask those questions about huge things like religious beliefs
Right.
and and faith and stuff, led me down a path that I wanted to be someone who asked those questions about everything.
That's awesome.
And I think it's cool.
And you weren't too damaged by being a double whammy preacher's kid.
No, I mean, I'm never going to be a pastor, but yeah.
Well, that's it. We've done our job. Thanks, Ruth.
Yeah,
I really
I'm
appreciate
happy
you
to do
sharing
this.
this with
Yeah.
us. And thank you for being my first experiment. I know because you're comfortable teaching via Zoom that you would be a good person to be my first interview. So
Yeah,
thank you
happy to.
for doing that.
Can I open myself up to community questions? Is that an okay thing?
Sure. So
Yeah.
that this will be posted um,
Hmm.
in our e-news. And so if people want to ask any follow-up questions, I'll put my email with it and I can
Hmm.
forward them on to you. And or if we get enough questions submitted, maybe we could do another session where we answer those questions.
Hmm. And that includes too, if there are young people that watch this that are interested in graduate education,
Yeah.
um, please, I'm happy to help answer those questions. But also anyone that has any questions about science literacy, um, science in general, or specifically what I do, I'm happy to answer those.
That's awesome. Thank you for being a good ambassador for higher education.
College is important.
Yay. All right. Thank you, Ruth.
Yeah, thank you so much. Happy to do it.